This is 7.2a of geometry. So we're going to talk about similar figures. We've talked about congruent shapes before, right? Remember we proved that two triangles were congruent. And that was when all angles were congruent and all sides were congruent, right? Basically they were the same shape. You could stick one on top of the other and they'd overlap perfectly. Well, now we're talking about similar figures. So congruent figures are considered similar figures, but most frequently what we're looking at is something that's smaller and then one that's bigger. Okay, if you think of like on the computer, it's kind of like you took it and you stretched the image. So, and we use the tilde, the squiggly, to say that they're similar to. So you would say like triangle ABC is similar to triangle XYZ. Okay, so here's a picture of it, giving you a shape. When we have similar figures, all angles are congruent, okay, and that's listed over here. And all the sides are proportional. Okay, so if side BA was 3 and side HG is 6, right? We doubled that. We times by 2. So if this is 2, then this one must be 4, right? 2 times 2 is 4. And if this one's 4, this one is 8. And if this one was 5, then this one's 10, right? However you get from this side to this side, right? We times it by 2. That's the same thing that you're going to use to get from this side to this side. Okay? And we'll have a little bit more specific way of doing that. And an extended proportion is what we saw on this last page. Right here. Here's our extended proportion saying that the proportion of every side is equal. So that's what an extended proportion is. And the scale factor, what I was talking about, how you know how we double it, or we times it by 2, that's your scale factor. Your scale factor is going to be one of these guys, and that tells you how to get from one length to the other length. And we write scale factors as ratios, so you can write it as fraction ratio, or you could write it with the colon as a ratio. So, we're going to do our got it problem. They give us this similarity statement. DEFG is similar to HJKL. So, if you're a visual learner and you want to draw out some four-sided shape and label them, that works. But if you think back to, we did it when we were working with congruent triangles where we just looked at the statement and could do it. So I'm going to do that here. So we said that all angles are congruent. So I can use the first letter, angle D, and the first letter of the other one, so angle H. Angle D is congruent to angle H. Then I can use the second letter. Angle E, is congruent to angle J. And then the third letter, angle F, is congruent to angle K. And angle G, the last letter, is congruent to angle L. So all four are congruent. And then we need to set up our extended proportion with the sides. So I'm going to take the first two letters, DE, and they go over the other first two letters, HJ. And that's equal to, and now I'm going to use the middle two letters, so EF over JK. And then I'm going to use the last two letters, FG over KL. And then I need to use the last letter and the first letter, so GD over LH. So all four pairs of congruent angles, and then I set up my extended proportion with all four sides. If you wanted to stick all the bottoms on top and all the tops on bottom, so basically flip over every single fraction, that would also work. You just need the top to be one shape and the bottom to be the other shape. Okay, let's look down here, and we're going to do our got it problems and figure out if these polygons are similar. So we're going to look at the angles need to be congruent, and we also need to check the sides if they're proportional. So if these are rectangles, right, because they've got the four right angles, I know this is also 15, this one's also 10, this one's also 20, and this one's also 10. So I'm going to start with this side here. Okay, so I've got 15, this one, and that goes over this side, so over 15 equals, and then 10, this side, over 20 equals 15 over 15 and equals 10 over 20. 15 over 15 is 1, but 10 over 20 is a half. Already I can stop. 1 is not equal to a half, so these shapes are not similar. And maybe you could just see that already from looking at it, but not similar. Okay, let's check out this other problem. So all of our angles are matching up, right? Here's 2 lines, 2 lines, 1 line, 1 line, 1 line, 1 line, and the rest are 90-degree angles. So I'm going to start with this side right here. So we've got 12, this one, over, well that matches up with this 6. So 12 over 6 equals, and then I'll go down, I got 12 again, over 6 again. And then I went towards the right angle with the 18, over and go towards the right angle, right? So that's 9. And then we got 18 again, over 9, and 18 again, over 9. So 12 over 6, that's 2. Again, 12 over 6, that's 2. 18 over 9, that's 2. 18 over 9, 2. 18 over 9, 2. So they're all equal. So I can write a similarity statement for this. So we started, well, let's start here and go around. So A, here I'm going to use a different color so we don't have so much green going. A, and then I'm going to go this direction. So A, B, C, D, E is similar to, and then I need to start at S and go this way. So S, R, V, U, T. And our scale factor is this right here, 2. So our scale factor, and we want to write it as a ratio, so I'm going to write it 2 to 1, or you could write it as 2 over 1. That would work as well. And there's your homework.